Good morning and good afternoon, and welcome to this conversation on Edge. This is part of a report, Getting Edgy, by Senza Fili in collaboration with FierceWireless. And today I'm talking to John Reister. He's the SVP of Product and Marketing at Vasona Networks. John, thanks for being with us today.
Thank you for having me.
So we've been talking about Edge for quite some time, but maybe you can tell our listeners who are you and what you do at Vasona.
Sure. I run the product team and the marketing teams, but Vasona is about multi-access edge computing, and we're deployed between the RAN and the core. And it's a place, very strategic place in the network from which we can provide, not only value-added services, but also, some network functions that help make the network more efficient and improve the quality of user experience.
How do you improve the quality of experience?
Sure. Well, we're in line, as edge computing is. We're in line and we see all the traffic from the users, and we have traffic management network function, and the traffic management network function is able to see the contention within each cell, sees which users are fighting for the same resources within a cell, and then can classify all that traffic into the traffic types, figure out which traffic is time sensitive and needs certain latency and bit rate to have a good experience. And then we manage the traffic by running it through queues and then releasing it to the RAN in a way, and getting feedback from the RAN continuously in a manner such that we can get the time sensitive traffic through when it needs to. And what that means is when you have peak demand, you're getting much better quality in the network. And that better quality in the network means, your users are happier, and you don't have to invest as quickly in new carriers in the RAN to accommodate those peaks because, we can manage the quality during those peaks.
Yeah, so by moving the management to the edge, management and content to the edge, clearly you improve the latency. And ideally, you want to push everything as much as you can to the edge because then the latency drops even further. But at some point, it's a trade-off in terms of the cost you introduce to do that and the advantages that you get. What is your view on how can you manage that trade-off? What is the business case behind it?
Yeah, sure. I think that, the key to MEC and getting it deployed is to have a good business case. And so, what we're really doing is by being close enough to the edge that we can understand the contention within the cell. If you're trying to do this from today's data center, which is over where the network connects to the internet, you're too far away to be able to effectively manage that and manage the contention within the cell. So we're close enough to the edge to manage that contention, which gives us, that provides a business case because it makes the network more efficient and improves the quality for the users. And then obviously when you want to introduce new services, low latency services, you don't want to have to go all the way through the extra router hops, through all the elements in the core, and then over to a data center, potentially to a CDN. So if you can bring that out to the edge with MEC, then you're able to have those low latency services.
Mm-hmm. Absolutely. So there is one part is the new services that you can support. That's a clear benefit. Now, the other one, I think it's very interesting, but it's a little bit more subtle because it makes us think about the infrastructure in a different way. You just don't look at just the cost of deploying a base station or an operator, but how efficient the use is. So how much money you can extract from it. And so the utilization becomes important. How do operators, can go about that to evaluate? Because it's a new way to look at the business case.
Yeah, absolutely. So there's, the analytics that you get out of the MEC platform mean that you're able to look on a cell by cell basis and figure out, what kind of, how good the services are that you're providing to them. You can figure out which cells are, the lowest, video bit rate, or which cells are, have high browsing latency, for example. And you can do that and now understand on a cell by cell basis. And by understanding that much better, you can, focus and choose where to invest in your network much better. So
Yes.
yeah, that definitely helps, and is part of the business case, getting those better analytics and understanding how to, focus your investment.
Now, one thing is, so one dimension is the edge. So move the traffic management to the edge. So that's one thing. But you talk about different traffic flows. And so what that brings to mind slicing, because you have two dimensions. Move it to the edge, sort of horizontal, but then there is a vertical dimension as well, which is slicing. Do they work together? What's the relationship there?
Yeah, very much. MEC is the key ingredient in slicing. And I think slicing, has been really talked about in the 5G context. And it's also been talked about from the standpoint of you're taking a whole device, you're taking a whole RAN slice and a core slice and almost physically, carving it up. And I think that's a start. But first of all, I think there's a lot of devices that are multifunction, and you really want to be able to, take, somebody who's using a smartphone and, be able to take, an app that they're using on the smartphone and map that into a slice. So I think it needs to be more dynamic, more flexible. I think you don't want to carve up the bandwidth that leads to underutilization and inefficiency. So you want to dynamically recognize, the content in the app and be able to provide that. I really think, part of MEC is edge breakout, and edge breakout means that you can take certain apps out of their, GTP tunnels, bring them, out to the edge and host those apps out at the edge, whether it be gaming or in IoT or connected vehicles. And you can host that function out at the edge, which means you're, injecting the traffic into the tunnel, shooting it down to the user, and on the uplink doing the reverse, pulling it out and being able to process it. And all those things means you're creating, a set of apps. You have a set of network functions. You're marrying it to traffic management to manage through the congestion for lower latency. And you're bringing this all together, and you're really creating a toolkit for the operators where they can now assemble those in a very agile, flexible way, and can assemble those into a service, whether that be a retail capability that they're offering their own service, or a wholesale capability where they're, providing these pieces in the form of a slice to a third party to create a service. And so I think that's really the heart of, the evolution of for the operators going forward and heading towards 5G, that they're able to play a much bigger role in the value chain and the delivery of these services, evolving from, moving bits back and forth and moving bits around to being able to provide more of these, more functionality and that bigger role.
And as you say, slicing makes much more sense if it's in real time. Now, if you do that, however, you need to know exactly what's going on. So that sort of goes back to the importance of analytics, because you need to have good analytics in order to do the real-time bit, because otherwise there is no point being over real time if you don't know exactly how to, exploit that opportunity there.
Yeah, and I think real time means you want to, you can have a static situation where you've got a device that is, it's an agricultural drone, and everything from that is always going to be in that particular slice. But, when you have a smartphone and the user's firing up, something, video or augmented reality or something, you want to dynamically recognize it. And then, of course, there's another aspect of the dynamic nature, which is the fact that, when you have congestion and you have to manage the traffic, you want to be able to classify it, recognize it on a packet by packet basis as the flow is happening, and be able to treat it accordingly. So it definitely needs to be very real time. Situations and conditions in the RAN can change in a matter of milliseconds when people hand over from cell to cell. A cell can go from being uncongested to being very congested in a second.
Yeah, and and also this creates a huge opportunity for mobile operators in terms of having they are the ones that can actually do this. So if you have an edge infrastructure that is outside the network, that is controlled by CDNs, for instance, in that case, they do not have the visibility, they don't have the ability to actually manage. So it's something that operators have to do it. So that should put them in a better position to market there's that service, that as a service to third parties, like, as you mentioned, wholesale partners. How do you see that developing? Do you think that the wholesale partners, who are they, and are they willing to eventually pay for it?
Well, I will say that, today you've got the cloud, and the closest the cloud can be to the edge is not very close, right? It tends to actually be relatively centralized. The operators, as that cloud and that data center moves, you're now able to create this edge cloud, and the operator is uniquely able to create that edge cloud. And so I absolutely think that enterprises, will want to rely on the operator to provide, that kind of functionality. And, who's gonna use it? It's going to be everybody from, the Ubers and the financial enterprises who have campuses. MEC can go all the way out to to being part of a small cell deployment in a campus environment. So I think it covers the whole range, and I think we can only imagine the industries that are going to be heavily benefited and enable new innovation because of these capabilities.
Now let's talk a bit about use cases. Video is clearly the first one because so much of the traffic is video. What else, or what is, anything new and special about video, or what are the other use cases?
Yeah, so video is a big one, and of course that evolves to 360 and augmented type reality. But I think there's really strong near-term business case for some other applications. Mobile gaming is a huge one. There are trends and initiatives in the mobile industry where a lot of the compute capabilities, the GPUs and so on, are being in the cloud, but frankly on the mobile network they're just too far away today. And with MEC you can actually bring that kind of capability out close to the edge, and you can actually really create a capability for mobile gaming, and it's a proven market. Users are able to, they have situations where they're paying on a monthly basis for access to multiplayer online games, and this is now something that the operator can play a role in. So I think that's a big one. I think IoT on factory as well as things like agriculture, and then smart city. There's some apps, and this ties back to video, but I think a lot of the video is now uplink and not just downlink. So you have cameras deployed around cities. You're able to do motion detection. You can detect the pedestrians and cars and their speeds. You can use that for traffic, for lighting, for security. So there's a lot of capabilities there that are going to really usher in, the future here and new innovation and how, people work and live.
Now, gaming, I think it's an interesting issue because not everything in gaming is local. So because you're playing with other people that are wherever else in the world. So you cannot just take everything to the edge. So how do you manage that? Because even within the same application, as you were talking about, you need to manage slicing at the application level. But here we're going even beyond the application level. There are different parts of a game that some is local, some is not. So some can be local, some cannot.
Yeah, sure. And the way that actually works is, so when we do the edge breakout, we can have caching at that point. So there's multiple kinds of breakout, by the way. The kind we're talking about here is what I call originate terminate. So the breakout comes to that VM that would be at the, hosting the gaming functions. But then you can then connect that via, a VLAN to a private cloud. It doesn't have to then go back through the core. It can pass, around the core, go to a private cloud for connectivity to, other participants in that ecosystem. And the way gaming in particular works is what's coming from the other users is not a video stream, it's telemetry information. So what you're getting from the other users is, this user is using this avatar, they're in this position, they just, did a shot or, whatever. And that then goes to the edge cloud that's servicing, you, and that's then assembled into a video image that captures all that information is delivered to you. So you still have connectivity to the other users, but it's, it's actually much lower bandwidth. Mm-hmm. Going out to all the other users.
Okay, yeah, that's interesting. Now, another aspect is when you have mobility. So you have mobility and edge infrastructure. So as you move, you transition from one edge node to the other, or you might, like with connected cars. How do you manage that?
Yeah, so we're, Vasona is currently deployed on 150,000 cells already in the Americas and in Europe. And we're deployed in an aggregation site, and it generally handles several hundred eNode B cell sites. And so quite a bit of mobility can actually happen within the same instance of our platform. The actual sessions that users have, even when you're watching a half-hour video, that ends up generally being broken up into sessions, because once you accumulate a certain amount of video, you transition to idle, and then you pull some more. So when there's a session change, the session can be reestablished, and if you've moved, it could go to a different instance. But in the cases where a session, is active and it hands over such that it's between different MEC instances, then you have to relay the state for that user between the MEC instances. And that definitely does get more complicated.
Absolutely. Now, we have to talk about 5G, clearly. That's the topic for every interview or anything. How does Mac relate to 5G or your solution? Because sometimes, I hear sometimes from operators and say, well, we need, whatever it is, we need to wait until 5G, because that's sort of like, we're kind of like, we need to wait, and then slicing is the same thing, wait until 5G. Do we need to wait until 5G? I mean, you already have deployment, so I guess we don't need to wait until 5G.
Yeah, definitely not. You don't need to wait until 5G to get MEC benefits. You can get capital efficiency benefits today. You can get user quality of experience benefits today. You can get latency benefits today on the 4G networks. But it absolutely is fundamental for 5G. So today's slicing that we can do with MEC on 4G does not include the slicing the RAN or slicing the core, right? It's just chaining together apps and network functions in the MEC location and part of the edge cloud. So it doesn't include those other pieces until you have the 5G part. But 5G, it's really high bandwidth. You've got a lot more antennas. you're going to really, in order to make it affordable, you're going to need to virtualize, the BBU and locate that in a CRAN site. And really what you want to do then, once you're in that CRAN site and it's virtualized, you're able to then bring in the MEC VMs as well. We're just software. We can be moved out to that site, no problem. So I think as things go to 5G, it's going to, gradually shift from, the edge of the core and aggregation points out to what we'd call the hub site, which is now handling maybe 10 to 20 eNode Bs, and that's where you also have the virtual BBU functions as well. So it's all part of the evolution to 5G, and MEC really lays the groundwork. It's the foundation. It's giving you the ability to have caching and low latency applications and classifying the user traffic and redirecting that user traffic into different network functionality and service chains. So I think that's fundamental, that whole transition towards 5G. MEC is a crucial building block of that.
Yeah, absolutely. So you need the Mac in order to get the full benefits of 5G. Now, if you go one step backwards, however, for Mac, it looks like you do need a virtualized network to actually, you can have edge infrastructure without virtualization, but it would be much more complex. So virtualization also enables and makes edge cost-effective, feasible, and not overly complex, right?
Yeah, and we do have deployments with clusters of bare metal, and those clusters of bare metal, you can add in virtualization layers to that, and then just move the MEC software up a few layers above that. But absolutely, in order to get the benefits of the service chaining and the agility, it absolutely has to be virtualized. And I think operators are in various stages of that. We're big supporters of OpenStack. And being able to host the VMs, ultimately evolve to containers for the various functions. And there's for MEC, there's GTP proxy and traffic management and traffic steering, and there's SCTP proxy and being able to detect which users are in the cell. So there's a whole bunch of functions, and all those things are virtualized and in VMs and can be deployed on that NFV infrastructure.
Now, let me ask you a final question that is sort of like, as we went through the interview, it's clear that you enable a different type of role of the mobile operators in the overall ecosystem. And clearly their role is changing. How do you see mobile operators' role changing from your end? And what kind of change that you are facilitating?
Yeah, and I think, mobile operators are pursuing different strategies. They're related, but you see some operators acquiring a lot of content, and clearly they want to be a retailer. And you see, other operators where they're just building out their network capabilities and not acquiring a lot of content. And that varies regionally, right? Whether it's in North America versus Europe and Asia and so on. But I really do think that the operators have, as voice has declined in terms of the contribution to revenue, and data has been primarily just plans for how many gigabytes, and the value add, the portion, the role in the value chain is really moving the bits and just creating connectivity. I think they've gotten themselves into a little bit of a bind where ARPUs are flat, and 5G demands a huge investment, and even in 4G being able to keep up with the traffic growth demands investment. So I think their role has to evolve, and I think MEC is absolutely fundamental to that. It really provides the ability to chain together these capabilities, network functions as well. And network functions include things like analytics, It includes, you know, traffic classification. It includes security and filtering, caching, you know, video analytics, you know, being able to find a license plate in a video stream, and, you know, things like that, and hosting those capabilities, and then providing them as a toolkit for, you know, other entities to assemble services. You know, that just substantially evolves and changes the role of the operator, and affords them so much more opportunity to create value for the communities that they operate in. So they'll, you know, they can be a true partner to you know, the communities, you know, local governments, as well as to, you know, innovators in all different industries, where those innovators will now have so many more tools to make use of as they're assembling their services.
Absolutely, and basically this gives them a way to leverage a lot of value that currently is not being leveraged enough. So
Exactly.
it's really moving forward and getting the value out of their networks.
That's it. That's the key.
Well, John, thanks so much for sharing your thoughts with us today.
Thank you for having me, Monica.
And thank you all for listening in. This is a part of a report, Getting Edgy, by Senza Fili in collaboration with FierceWireless, that you can download. Thank you very much.